This is page 118 of your math journal. We're going to call this one exponents. Properties and expressions. Okay, first thing I want you to write is what an exponent is. An exponent looks like this. Let's say you have 3 with a little 2 there. That means 3 to the second power, so that'd be 3 times 3. Okay, 3 is considered the base. And 2 is the power, or the exponent. Okay, order of operations is another important thing to remember. Remember GEMDOS? Okay, G, E, M and D go on the same line, so do A and S. Okay, G stands for grouping symbols. Okay, grouping symbols like parentheses, brackets, braces. Okay, it just means this group needs to happen together first. Then exponents. Exponents, we just reviewed what that meant. Okay, then multiply or divide. But you have to remember left to right. This is clue or key. If you don't do it left to right, generally you might mess something up. Okay, then addition and subtraction left to right. Neither one is more powerful than the other one, but it matters what comes first. Alright, so let's say you have an expression like this. 10 plus 2 parentheses, or sorry, 10 minus 2 parentheses 4 plus 1 plus 4 to the second power. Okay, if this is what I have, then I've got to do inside the parentheses first. So I'm going to do the 4 plus 1 first. Now I know add and subtract is last, but because it's inside the grouping symbols, I'm going to do that first, and that would give me 5. So that becomes 5. I just bring down everything I haven't changed. Now this 2 on the outside of the parentheses just means times. So bring down everything that we haven't changed. Okay, next come exponents, so I'm going to do this next. 4 to the second power means 4 times 4, that's going to give me 16. Bring down everything we haven't changed. 2 times 5 would be next because that's multiplication. 2 times 5 is 10. Minus, okay, bring down everything we haven't changed. Oh, I meant to do that in blue. This is the part that changed. Okay, now add or subtract left to right, not add first. Whatever comes first, left to right. In this case, it's 10 minus 10. 10 minus 10 is 0. Then 0 plus 16. Final answer is 16. Okay, but order of operations is key to making sure that you simplify those correctly. Okay, now we're going to talk about the properties. So these are the properties, but these only pertain to addition and subtraction. Sorry, properties. Okay, so these are either addition or multiplication. Okay, we have three main properties. We have the commutative property. To commute means to move. Okay, so a keyword is move. So example would be like 6 plus 4 is the same as 4 plus 6. It could also be 12 times 2 is the same as 2 times 12. Okay, we have the associative property. Associate means to move. Or sorry, it means to group. So the associative property means to group differently. So example could be like 2 plus 3 in parentheses plus 5 is the same as 2 plus in parentheses 3 plus 5. Notice how the parentheses moved here. This is a group, but here this is a group. Okay, also works with multiplication. 2 times 3 in parentheses times 4 is going to be the same as 2 times in parentheses 3 times 4. Okay, to associate means to group. That would be your associative property. Okay, last one is the identity property of these. Okay, the identity property means it stays the same. So example of that, if I'm adding 8 plus 0, I still get 8. I added 0 to it and it stayed the same. Or in multiplication, be 8 times 1 would still give me 8. Either way, this number and this number stayed the same, even after multiplication or addition. Alright, little squiggly line here because this property is a little bit different than the others. Okay, the distributive property. This is probably the one I want you to remember the most of all of these on here. Okay, the distributive property shares multiplication. Okay, underline shares multiplication and add or subtract. Okay, so with that example of the distributive property, if I have two groups of 3 plus 4, I'm going to share that multiplication with everything inside. So I'm going to do 2 times 3 plus 2 times 4. See how I've shared the 2? Okay, we can also do that with variables. Sometimes we can go backwards. If I had, let's say we have 3v plus 6. What is shared here? 3 is shared with both of these. So I could say that this is the same as 3v's. I can also say that this is 3 2's. So that would be the same as 3 groups of v plus 2. Okay, there's your distributive property. You can go back and forth, but it can be super useful sometimes. Okay, Next one I want you to write down is what an expression is. Okay, expressions are numbers and operations. Okay, important to note there is no equal sign. Okay, numerical means just numbers. Numerical. It's only numbers. An algebraic expression is variables and numbers. Okay, example of a numerical expression would be like 2 plus 4. That's a numerical expression. Okay, algebraic expression would be like 3 plus d, or 4m, 4 times m. Okay, those would be algebraic expressions. Another numerical expression could be 4 times 6, whatever. These just have numbers. Alright, so sometimes we need to know how to simplify expressions and know what equivalent expressions are. So simplifying expressions and equivalent expressions. Okay, so which of the expressions are equivalent below? So we're going to figure this out. Which of the expressions below are equivalent? Okay, let's start with 10x plus 4 plus x minus 1. Okay, another one would be 11 groups of x plus 3. Another one, let's do 20x minus 9x minus 3. And let's do 3 plus 11x. Okay, before you can tell me which ones are equivalent to each other, you have to simplify them and see that you have the same amount of each term. Now remember, you can only put together like terms. So over here on the side, I want you to remember like terms means same variable. Okay, like terms we can put together. So in this expression, 10x plus 4, I can't put them together. This is x's, these are not x's. However, I have 10 x's here plus another x here. So I can put these two together. So 10x plus 1 more x, that gives me 11 x's. Okay, I can also put these together. Okay, at the end of the story, I get 4, I take away 1, I am left with 3 of them. So this is as far as this can go, 11x plus 3. That is our simplified expression. This one here, I have 11 groups of x plus 3. That means I have 11 groups of x, so I'm going to distribute here. That would be 11 times x plus 11 times 3. So 11 times x would be 11x plus 11 times 3 would be 33. X's, not x's, can't put them together. This is as simplified as I can make it. Are those equivalent to each other? No, 3 and 33 are not equivalent. So those are not equivalent expressions. Okay, looking at this one, put it together like terms. 20x's minus 9x's. I can put those together. 20x's minus 9x's, that's going to leave me with 11x's. Now minus 3. I'm still minusing 3. I can't combine that with anything else. That is not the same. That has a minus 3. That has a plus 3. So that makes them not equivalent. This one here, simplify it. I can't do anything more to this one. I have regular constant numbers. So this is called a constant. And I have my variable. I cannot combine them. 3 plus 11x is the same as 11x plus 3. Because of the commutative property, I can rewrite this like this if I wanted to. They're the same. So that means that this one and this one are equivalent. So this expression is equivalent to this expression. Okay, just a couple more terms I want down here. A constant has no variable. So in 11x plus 3, that would mean 3 is a constant. Okay, and one more is a coefficient. And a coefficient is a number multiplied to a variable. That would mean up here, 11 is a coefficient.